Just did some test cutting on some 1/2 inch plate. Don't look too bad. This is supposed to be a 1 inch by 1 inch square. There was a little dross on the bottom I knocked off. Looks pretty good. 60 amps, 27 inches per minute. Now let's see how close to 1 inch we are. I'd say that's pretty close. Now let's go this way. And I'd say that's pretty close. Pretty good edge. This is making fast work of cutting 16 gauge, doing a star shape at 500 inches per minute. Not too bad. If we got a lot of parts to cut out, we could get them done quick, fast, and in a hurry. 120 inches per minute. About 18 minutes cut time after the drawing and programming.
That's exactly what I found with LearnBest. LearnBest provides unlimited access to content. User-friendly decisions. No jargon, no confusion, just features. Make progress on your Mac. Click on the banner and head to LearnBest.com to create a free
cutting some half-inch parts, using the scribe to accurately locate some holes. Sure, I'll get them for you. Wanted to make a short little video showing some of the features of the Wolf's Metal Fabrication CNC plasma gantry. And so I suppose we'll get started. Here's the Z-axis, and the Z-axis plate can be removed by removing those 4 bolts and sliding it down through the table slats in case you need to put a new different mount on for a different application or for cleaning. Then you can access everything behind it. And you can access everything on the back side through here, and for tightening and aligning your rails. And we have the ball screw and ball nut that you can access from the back side as well. And then the upper bearing mounting block has double opposing bearings to secure it very accurately. And then the motor coupler allows for proper alignment and securing of the motor mount. And it's built for NEMA 23 motor that will just bolt right down here, or with an adapter plate you can run a NEMA 34 motor and a different coupler. And then the what I call X-axis on this table, you can see the spring-loaded spur gear engagement here, which is adjustable tension. Gives it nice solid contact, no backlash, no gap. And then the V-rollers for the X-axis linear guide. The lower ones are adjustable with an eccentric, a hex eccentric right there. And all of the bearing blocks for the Z-axis linear rails are secured on the back side there. And then the pivot point for this makes use of a shoulder bolt and drilled and reamed holes so that you get a nice tight no slop fit. And then your motor, NEMA 34 motor mounts here, access to help get the pulley installed and get the bolts tightened down, and the proper gearing with better than XL timing pulleys so that you have good positive belt engagement in the pulleys and no backlash when changing directions. And then the cable carrier is a 1" by 2" inner diameter, which will serve most people's needs but can be made larger if needed. And then the bracket here that holds it, if you are putting a scribe on, this can be changed out for the bracket that will hold the scribe regulators and such. And depending on your preference, this bracket can be bent the other way and installed on this side, and the cable carrier run the opposite direction for the wires to exit. The wires are made to exit through that carrier down this track and then into this carrier, which is just a short section to show you here for now, and then down your long axis. And the motor and limit switches from the other side come through the tube, through this grommet and in here, so all your wires are flowing nicely to the machine and to your control box. And this bracket here, for your preference and or table build, this bracket can be flipped up or down, and this mounting tab on the cable carrier can be mounted, flipped and mounted on the top or bottom. And this this one connector on the cable carrier can be removed too if you need better access for your cable. And then for the main rails, the bearing carriers, they are rolling on and guided by double stacked roller bearings to give you nice long living bearings and a good rigid machine. And the limit switches are all installed in this end carrier. And then these limit switches reference on your end stop, and then our hard stop to this location. And your Z and X axis references to this switch and then has a rubber hard stop at that location. And you can see this is what it is without any motor in it. This is what it is like with the motor and wiring in it. And then there's also belt covers on the end for safety to cover up the belt, which are easily removed by these two bolts sliding it off to access your belt. And tightening is done by sliding in these slots. It's made for NEMA 34 motors, but with our adapter plate you can run NEMA 23 motors as well, if that's your preference. And it has a quick release pin, which I'll show you here in a second, and then spring-loaded spur gear engagement as well. And then the pivot point is an oversized machined bushing, is reamed to the proper size, also on a shoulder bolt. And you can see, maybe here if I can do this with the camera, spring-loaded to allow good proper engagement and no backlash. And then if for cleaning or adjusting, pull that down, quick release pin pops in, it is disengaged. You can clean or adjust, and then you just put some pressure down, pull the pin, and it releases back up. Once again, proper ratio, belt driven with the better than XL pulleys. And this cable carrier will be supplied the length that you need for your table. And for fine-tuning the adjustment of the perpendicularness of this rail to your table, and for squaring of the carriages and your tube, and getting everything aligned properly, and making sure both sets of your bearings, front and rear, are touching and rolling accurately. We have these set screws here on all of your mounting bolts to fine-tune how the tube fits in the carriages when you are tightening down these bolts. We are currently not supplying them with the torch mounts because of the wide range of torches being used, and whether you're using a floating head or a ohmic touch sensor. They are widely available. Solid mount, floating head mount, or magnetic disconnect. And we probably will offer them in the future, but for now, to get this thing rolling, we are not going to offer them. You can also mount a router or other scribe on the main mounting plate. On our table we are using, it has made a couple improvements since then, but it has the scribe mounted offset, which we have allowed in the size of this gantry for a torch mount and a scribe that is offset, and for a little bit more length or width than you need for a 4-foot wide sheet, which we can offer these in 5-foot wide or whatever you want as well. But that way, you, like for a 4-foot machine, you got 49 inches worth of usable space for both tools, so you don't have any dead space. And I did forget to mention the bearings on the bottom just slide in and slide out. So in order to install or remove this gantry, you will need to loosen up the pulley and slide the spur gear this way, and when it hits this bearing, that's enough clearance to lift it off, and then you just loosen these bearings and they slide out, allowing you to remove it or install it on the table. And these, to install, you just push them up, hold with a wrench in here and tighten them up, and then they will be in contact as needed to secure it nice and solidly to the rails. And you can see it's got nice and positive movement. I will post up some videos that show, I already have some, but I will try to organize it a little bit, put together different cutting applications, cut quality and such from the existing table that is being used. And I don't think I mentioned, I will in the future hopefully get the scribe option added as well, for those of you who are wanting that. The X-axis rail is the V roller so that it's self-cleaning, and then since the Z-axis isn't super long, which it is plenty long for its application, you have 6 3/8 of an inch of clearance between the bottom of the Z-axis head here and the table, and full travel of the plate if needed. Normally you won't need it all, but it is there if needed. But the linear guides we've used on that are recirculating linear ball bearings grouped on the back side, and they are actually mounted to this and to the frame, and then the rails are actually mounted to the plate. That way when it comes down you have extra rigidity and strength on the plate, and you always have support as close to the bottom as possible, unlike some that are done in the other fashion. And this table I have drilled and tapped the gear rack, and that is an option. You can do that, but you can also use the VHB tape to secure them. And as far as the table that you need to build to sit this on, it is pretty simple. If you follow our design, it uses 2 by 3 by 1/8 inch wall tubing. The main rails going this way, and the front rails in the front and back this way, and then the legs right behind it going straight down, and then a smaller like 1 by 2 connecting it down at the bottom with threaded adjuster feet to level the table. Something that can be easily fabricated by you welder and fabricators. This top rail, instead of welding it, it is a good idea to weld a plate to the tube and then bolt it to your leg and front and rear tube assemblies. That way when you bolt it here you can fine-tune adjustment of this tube to make aligning this rail easier, and to make sure that it is flat and parallel with the other one, level and such. On this one I did not do that, and I ended up drilling and tapping set screws to help adjust and make the rail level and flat. This also does allow, with the large clearance here, the addition of our RTC1 rotary chuck, which this is one of our early prototypes and works on our machine. The production model is a lot larger, and the motor is installed inside the unit.